Hello algebra students, welcome back to Algebra 1, and today's lesson is on solving quadratic equations using the quadratic formula. There's one part about, two parts about the quadratic formula that are important to know. One is there's something in the quadratic formula which is called the discriminant, and that is the expression b squared minus 4ac. Now this is nice because it not only gives us a value that we have to plug in, but it also tells us the number of solutions the quadratic will have. Remember, a quadratic equation can have either 0, 1, or 2 solutions. Now, the quadratic formula, a lot of us will see it as x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. But, if you notice, this discriminant is right there. Now, personally, I think it's better to evaluate the discriminant, determine how many answers you should have at the end, and then once you know, you can plug everything straight into the quadratic formula. Now, you have to remember, the first step is to set the quadratic equal to 0. Alright, you should have everything on the left side of the equation and set it equal to 0. So let's take look at a couple of examples here. So number 1 here, you have x squared plus 3x minus 18. So the first thing we're going to do is identify what a is, what b is, and what c is. Once we know what a, b, and c are, and signs are important here, okay, you're going to evaluate the discriminant. So I do b squared, and remember, anytime you square b, you must make sure the value of b is in parentheses. Minus 4 times 1 times, not 3, but negative 18. So once I evaluate this, and I basically put it in the calculator exactly the way I see it. Once I evaluate this, I get a value of 81. Now, since my discriminant is equal to a positive number, I know I'm going to have 2 answers at the end. Now, how do I find the answers? I use the quadratic formula. So if b is positive 3, the opposite of positive 3 is going to be negative 3, plus or minus the square root. We don't have to evaluate b squared minus 4ac again because we already found it out to be 81. So we do the square root of 81, all over 2 times a is 1. And now you're probably asking, where do my 2 answers come from? Well, this little symbol here tells us where our 2 answers come from. So the first part is to take negative 3, add the square root of 81, which we should translate right away to 9. All divided by 2 times 1 is 2. And when we add the numerator, we get 6 divided by 2 is 3. Now my other answer, instead of adding up top, now I'm going to go ahead and subtract. When I subtract up top, I get negative 12 divided by 2, which is negative 6. And these are the 2 solutions to your quadratic equation. If I wanted to check if I'm right or wrong, plug each solution in independently. It's 3 squared plus 3 times 3 minus 18. Is this going to make a true statement? 9 plus 9 is 18. 18 minus 18 is 0. I know that's a solution. And the same thing would happen if I plug in negative 6. Okay? Next example. And look, in this example, a is equal to 12, b is equal to negative 11, and c is equal to 2. So we go ahead, we evaluate the discriminant. Negative 11 squared minus 4 times 12 times 2. When we evaluate the discriminant, we get 25. Again, all you are doing to evaluate this is plugging it in a calculator, making sure b squared is in parentheses. Okay, so I go ahead now and I find my solutions using the quadratic form. X equals the opposite of b. If b is negative 11, we're going to have positive 11, plus or minus the square root of our discriminant, which was 25, all over 2 times 12. Now, to find the 2 solutions, I go ahead, I add the numerators, the square root of 25 is 5, all divided by 24. If we simplify this, we get 16 over 24, but we should go ahead and reduce it. And notice here too, I evaluate the numerator, and then I just quickly divide by the denominator. When I divide both by 8, I get 2 over 3. My second solution would be 11 minus 5 all over 24, which is going to give you 6 over 24, and that would reduce to 1/4. These are the values of x that when you plug them back in will make the equation true. Now the next one. Is our quadratic equal to 0? Yes. So if I identify my a, my b, and my c, I end up getting, for my discriminant, right, b is negative 2, so negative 2 squared minus 4 times 9 times negative 16. And if you evaluate that in your calculator, you will get 580. Now I can go ahead and find my answers. X equals, if b is negative 2, the opposite of negative 2 is positive 2, plus or minus the square root of 580, all divided by 2 times 9. Now you should notice 580 is not a perfect square, so you have to make sure that you evaluate this in the calculator correctly. So you do 2 plus the square root of 580, all divided by 2 times 9 is 18. And when you put this in your calculator, do me a favor, put this in, hit enter, and then divide by 18. Okay, you have to evaluate the numerator first. When you evaluate this, you get 2.80 in your calculator. My second solution, now I'm going to subtract the square root of 580 and divide by 18. And when I do this, I get negative 2.45. And those are your two solutions. Do me a favor and pause the video to make sure you get those same answers, because evaluating those expressions is one of the common mistakes students make. Alright, next one. I have A, I have B, and I have C. And when I evaluate the discriminant here, something interesting will happen. So I get negative 12 squared minus 4 times A is 4 times C is 9. When I evaluate the discriminant here, I end up getting a value of 0. Now one thing you need to know is if your discriminant has a value of 0, what happens is you're only going to get one solution. So to find the one solution, you can do the same thing. So you get 12 plus or minus the square root of 0 all over 2 times A is 4. But you notice here, when you break up your two problems, you get 12 plus 0 divided by 8, which gives you 12 over 8, which reduces to 3 halves. But even if you do the subtraction up top, 12 minus 0 divided by 8, you get the same answer. But you only have to write it one time. So this quadratic will only have one solution. Okay? Now the next one. If you look at number 5 here, is this quadratic set equal to 0? No. So in order for our quadratic to be equal to 0, I have to get rid of this 2x. It's like solving equations in the first unit. How do I get rid of it? I subtract it. Can I line it up under the 5x squared or the negative 1? No. But where would it go? Right in the middle here. So I subtract 2x there. What I end up getting then is 5x squared minus 2x minus 1 equals 0. Once I have this, now I am ready to go ahead and use the quadratic formula. So I evaluate the discriminant. I get negative 2 squared minus 4 times 5 times negative 1. So I have my A, my B, and my C here. When you evaluate that in your calculator, you get a value of 24. Once I know my discriminant, I go straight to the quadratic formula. The opposite of B, which is positive 2, plus or minus the square root of 24, all over 2 times A is 5. So my two solutions, 1, 2 plus the square root of 24 all over 10. And if you simplify this, you get approximately 0.69. And we should always round to the hundredth for now. And now when we subtract up top, we end up getting an approximate value of negative 0.29. And those are your two solutions. So this one, we had to, the most important part is to make sure you set that quadratic in the original problem equal to 0. Now the last problem. Okay, if I gather A, B, and C here, I have A is 8, B is negative 4, C is 10. When I evaluate the discriminant, I get negative 4 squared minus 4 times A times C. When I evaluate that discriminant, I end up with negative 304. When you go to plug this in to the quadratic formula, the opposite of b is 4, plus or minus the square root of negative 304, all over 2 times 8, what happens is you get an error. That's because you cannot take the square root of a negative number. So anytime your discriminant is equal to a negative number, automatically you don't even have to go to the quadratic formula, right? All I have to do is put no solution, because there will not be any solutions to the equation. So that is your answer. There's no values of x that will make the equation true. Thank you for your time. Now go ahead and try the usual problems on your own. Thank you.